Hi, I'm Tammy and I do math for coffee. Today is the first lesson of the full geometry class. Lesson 1, points, lines, and planes, ... meaning like there's going to be some other stuff in here as well. In geometry, you have to start with some basic building blocks in order to create other things. And the first one is a point. Just make a dot and then you label it. And that's how we name them. We use capital letters to name our points. If you imagine you take an infinite number of points and put them all together side by side by side by side, but really, really close together, you would get a thing that looks a little like this, going forever and ever in both directions. So we put arrows on both ends, and that would be a line. Now, to name a line, we have to have a couple points. We aren't going to try to list all the points because there's infinitely many. So if I grab this one and that one, then I have 2 points on the line, and that's all I need to name it. So I can name this line BC, and then you put a little icon over the top that looks like a line. Or you could even go with CB, and you still have to put the little line icon over the top. And let's say you don't want to use the entire line going forever and ever in both directions, but you want to just talk about a piece of it. That would be called a line segment. And so it doesn't go forever and ever in both directions. In fact, it has endpoints. It can go back and forth, so I can't say this is the start point and that's the end point. We just call them both endpoints. I'll label this one D and that one E. Now, naming a line segment, you put the little icon over the top, but it doesn't have arrows on both ends. This tells me when I read it, when you write it down on a piece of paper, that you are talking about the segment D to E, or you can flip the letters and go from E to D. Okay, that was Bell. We keep pushing on. We did points, we did lines, and a line segment, and then plane. I'm not talking about the ones up in the sky. I'm talking about something that's flat like this, but imagine a piece of paper that's going forever in 2 directions. It's just a flat, level thing. We call that a plane. These are a little bit hard to draw on a piece of paper, so I do something like this. You have to imagine this thing is going forever and it has no edges on it. A piece of paper has edges on it, but this thing doesn't. Now, to name a plane, you have to have 3 points. I'm up to E, so this would be F, G, and H. To name it, I've seen it written down a couple different ways. You'll have to talk to your teacher about how they're going to do it. Usually in the textbooks that I've seen, they just use the word plane, F, G, H. But I have seen some where they put this little shape in front of it like this, and F, G, H. Points, lines, planes, now we're up to the ... part. For some reason, and I think it's because I'm a science fiction nerd, this is like my favorite one of these. It's a ray. Rays have an initial point, and then they go off like that. But they go forever in that direction. To name a ray, you actually need to have a second point on that ray. Here's the reason. You could have anything starting here, but you don't know which direction it's going, right? It could be going in any direction. If you're talking about this one, there'll be a point on the ray somewhere. This one will be I, and this one will be J. Naming them is very specific. We have to start with this one, which is called the initial point. The fact that I have an I here is just a coincidinky. Okay, this is called the initial point. It's where the ray starts. The start point for the ray. And so when you name them, you have to put that letter first. And then the second one that it goes through is this letter. And the little icon you put on there is just a tiny little ray. Okay, 2 rays that have the same initial point will look like this. And again, rays have to have another point that distinguishes them from one another. So what do we have here? This one will be my starting initial point. This one, H, I, J, K, L, and M. And then what we have here is an angle. We'll talk about angles more when it's time to talk about angles, but really the angle is this thing right here, is this little space, and how wide apart these guys are. That's the angle. The point right here is very interesting. Since it's the initial point for both, on an angle it has a different name. It's called a vertex. That's the vertex of the angle. When you name angles, sometimes you only need to have one letter. When we get in there, I'll explain in context why it might be a little different. But for today, I'm going to name this angle using all 3 points. There's 2 ways to do that. We could start at L, K, M, and you put this little angle thing in front of it. Now make sure you make that slanty enough so it doesn't look like your L, because it's not an L. This part's very slanty. Or I could go the other way and go M, K, L. Now, I did something very specific there. I can't start with the K because the K is the vertex. It needs to be in the middle of those 3. And we'll talk about that more as we get into the course and we talk about angles. Oh, hey, I almost forgot something. A couple words you need to know. Scroll back up to the top here. When you have 2 points that are on the same line, they are called collinear. So find a spot, write this in. Collinear means that points on the same line. How to remember that word? Couple ways. One, line is in the word, and another word you may be more familiar with in the real world is called co-worker, somebody that you work next to, somebody you work with. These points are on the same line. B and C are collinear. A is not on that line, so A is not collinear with B and C. So you're going to need to know that word. And there's a word that's very much like that. It's called coplanar, which means, is it AR or ER? I told you I can't spell. We're going to go with AR. Coplanar. Points on the same plane. Yeah. Okay, some parts of your brain shut off when you start recording for YouTube. It's a known fact. Okay, so F, G, and H are actually on the same plane, so we can call them coplanar, and you're going to remember that word because of that root right there. Plane, plan, plane, and line for collinear. All right, let's see if you learned some of this notation. I'm going to draw something. I want you to name it. All right, go ahead and name that. That's a line, so it could have been KR with the little line symbol over it, or RK with the little line symbol over it. Okay, that's the drawing. You name it. This is a ray, and this is the initial point. There's only one possible answer, and that is ST with a little symbol over the top. Okay, let's reverse this. I'm going to give you the name, and I want you to draw the thing. Here's the name. All right, draw that thing. Might need to pause. I'm coming right in with the answer. This is a line segment, and it has endpoints, and those endpoints are A and D. You could have put the D here and the A there. That's fine. They can switch. The only thing that can't really switch around too much is the ray. I'll give you another name, and I'm going to ask you to draw it. Draw that thing. Here comes the answer. Pause if you're not ready. Okay, that is a ray, and the starting initial point is U. So the U must be here and the Z is on that. I'm going to give you another name and you're going to draw it. Draw that thing. Here comes the answer. You ready? This is an angle, and the B is the vertex. So I have to make an angle. Yours can look different than mine, but I do know that this point right here has to be the B. It doesn't really matter which way the A and the C go on the drawing, but it should look like an angle, and that's what it is. Thanks for watching. I will see you in the next one. Bye. Segment addition, it's called segment addition postulate. Postulate's a fancy word for rule. Let me show you what the segment addition postulate looks like in a real simple way. So if I draw a piece like this, and let's say that that is 3 units long. I'm not going to put units on here, so it could be centimeters, inches, feet, whatever. Let's just call it 3. And then I grab another segment and I put it right up next to it, and let's say that this one is 5 units long. Of course, nothing is ever going to be drawn to scale. Then the question is how long is that whole thing? And you're all like, well, it's got to be 8. Just in case you don't see it, we're talking about the length of those two things combined. And so you figure that out by going 3 plus 5 and you get 8. That's the segment addition postulate. Pretty simple, but of course, you know, we're going to make it a little more complicated. I'm going to work 3 problems for you, and then I'll give you some practice problems to do. Example 1. I am going to have one segment that is the letter I to H. And this is the one I don't know. I don't know how long that is. I have another segment next to it that goes from H to G, and it is 7 units long. And I'm told that the distance from I all the way to G is 18. Whether I'm shown that in a diagram or I'm told that with words, that's what it means, is that the whole thing is 18. Now to solve that, we have to use what we know. The segment addition postulate says that if you have 2 pieces put together, you add them up. So this piece we don't know plus this 7 is going to equal that 18. So setting that up, I got question mark plus 7 equals 18. Tiny little algebra equation here. I'm going to subtract 7 from both sides. Question mark equals 11. And that is our final answer. Okay, example number 2. All right, we're going to find the length of TR. I'm given a segment that is starting at the point U and goes to the point T, and then there's another segment that starts at T and goes to S, and then there's another segment that goes all the way over to the last point, which is R. Some information that we're given is that this one is 9, from U to T is 9, from S to R is also 9, and then they're also told that from U to S is 14. So it's starting to get a little bit more complicated. They're asking us for is TR. So that means we need this piece plus this piece. We already know this one is 9. Well, we don't have a measurement for this distance that's going from T to S. They gave us this clue down below that the whole distance is 14, and we know the first chunk of it is 9. So it's just pretty much a subtraction problem. Subtract 9 from 14. So we know that this piece right here is 5. Then in order to answer the problem, TR equals 5 plus 9. I didn't really go over it too much in the notation. I'll go over it right now. If you're naming the segment, I'm over here on the side. So the name of the segment is TR. with a line over it. The measure measurer. Okay, hey, you know what? If you ever take my class in real life, you'll know I make as many mistakes as anybody. I just do them publicly. All right, so now we need to come up with the answer. TR equals 5 plus 9, 14. There we go. All right, example 3. There's a diagram we're going to start with. I'm going to make my line kind of long. I'll put some dots in here. This is J. This is K. Go a little bit and put an L and an M. My K looks funny. All right, the piece between J and K. This is where you're going to see some algebra. This is 4x minus 1. Now don't get freaked out. We already know how to do this with numbers, right? So that we're just going to use the same processes, but we'll be using algebra expressions too. K through L is 8. And then from L to M is negative 3 plus 2x. I don't know why we didn't just write 2x minus 3. Same thing, but okay, this is how it is. And we are given that the length of the entire thing equals 7x plus 1. We have to use what we know, segment addition postulate. You add up all the little things and set them equal to the total. So that means the 4x minus 1 plus the 8 plus the negative 3 plus 2x has to equal this. So I am going to take each one of these chunks, add them together, combine like terms, do some algebra stuff on it, but it equals this thing, the 7x plus 1. When we combine like terms, we're going to put all the x's together. A 4x and a 2x is a 6x. And then we're going to put our numbers together. We have a negative 1 plus 8, that's a 7. And then we have the 7 minus 3, so that's a plus 4, equals 7x plus 1. Now we have variable on both sides. There's more than one way to solve these, but my rule of thumb is to usually subtract off the smallest variable term. So 6x is fewer x's than the 7x, so I'm going to take that away from both sides first. Oh, I'm going to run out of paper. Have to get all squishy here. All right, so that'll cancel out, and we get 4 equal to x plus 1. And then we're going to solve for x. Now, there was no directions given on this, so I'm just going to assume we're solving for x. So we've got to subtract that 1 from both sides. This lesson usually happens very beginning of geometry, so I'm pretty careful with my algebra, so it's a review for a lot of folks. And we are getting 3 equals x. Now, for right now, we're going to stop there. But if they asked us what jk was, we would just take this x and substitute it in here. 4 times 3 is 12, and 12 minus 1 is 11. Pause and copy this problem and do it in your notebook. I will be right back to show you the solution. And this one's pretty straightforward. We're going to solve for x. 9 plus x equals 16. So you can make an equation out of it if you want to. Somebody's going to be screaming at me right now. It's like too easy. Don't do algebra on it. But that's the setup. You can practice your algebra even if it's kind of easy. And we end up with x equal to 7. Did you get that? I hope so. All right, here comes your second one. Here is your second. Try it. Again, pause, copy the problem in your notebook, and give it a go. I'll be right back. The entire length is 29. That means x plus 22 plus 2x plus 26 plus 11 equals 29. Now you can write that all out and then combine like terms, or you could do it this way, which is I'm going to combine the terms as I go. This has an x in it, this has two x's in it, there is no x here. 1x plus 2x, that is 3 x's. Just in case you forgot, if you just see an x by itself or any variable by itself, you have to remember there's an invisible 1 in front of it. So 1 plus 2 is 3. I have 3 x's altogether. 22 plus 26 is 48. And 48 plus 11 is 59. And equals 29. All right, now we have a two-step equation to solve. We need to get the variable piece all by itself. I'm going to subtract the 59 from both sides. So that cancels. We end up with just the 3x on this side equals 29 minus 59 is a negative 30. Now you're going to divide both sides by 3. And we're coming up with x equal to negative 10. And that might be freaky for a while, but you think about it, all you need to do is plug that in and make sure your segment lengths are positive. Here comes try it number 3. You're going to have to solve for x first, but eventually you're going to plug that in because it wants you to find EF, which I forgot to write the F, it's right here. So ultimately, we are looking for this length. But we won't find that until the end. We have to set up and solve for x first. So, like we've been doing, segment addition postulate says you add all these chunks together and you set it equal to the whole thing. So, 4 plus 3 plus a minus 2, that's 7. And a negative 2, that's going to be a positive 5. So I know I'm going to have a plus 5. I didn't do my x's first. This guy has no x's. This one has 3x, that has 2x, so it has 5 x's. And all of that needs to equal the whole thing, which is 8x minus 1. All right, now we have to start doing the algebra. There's actually 4 ways to start this problem. My preference for starting one of these when there's a variable on both sides is to deal with the smallest x first and get that thing canceled out. So I end up with 5 equals 3x minus 1. If I start with the smallest xc term first, what happens is I end up with a positive answer. I like to avoid negatives as much as I can because, again, I make mistakes just like everybody else. And if there's a lot of negatives happening, sometimes I make sign errors too. Now solving, we have to add the 1 to both sides. And we get 6 equals 3x. And then we're going to divide both sides by 3. And I'm coming up with x equals 2, which is freaking awesome. But that is not what we wanted. They wanted us to figure out what EF was. Well, that means we're going to take this little guy and plug it in right there. So EF equals 2 times this 2 minus another 2. Well, isn't that sweet? They all match. They're matchy-matchy. 2 times 2 is 4 minus 2, and we get an answer of 2. Okay. Man, look at that. Even if you stopped right here and said x equals 2, you might end up accidentally getting that right because your length equals 2 as well. Okay, well, I would never put that on a quiz if I was paying attention. Today we're going to talk about angles and their measures. First off, how to draw an angle. Start with a point, and then from that point, we're going to draw a couple rays that are going in opposite, well, not opposite directions, just different directions. And to make sure you can tell the difference between these rays, we're going to put a couple points, one there and one there. I am going to label this point that we started with A. That's the vertex for the angle. This is the vertex for the angle, but it's the initial point for each one of these rays. This one will be B, and this one will be C, and I'm just kind of making that up. So the parts of an angle, we already got the vertex, and then we know that AB, ray AB, that's the symbol for it, and ray AC are the sides. Now, the idea of the angle, these are the sides of the angle, that's the vertex of the angle, but the angle is actually this little piece right in here. And in a minute when we measure that, we're measuring how wide apart that is, very much as if you're working with a scissor. So the bigger the scissor is open, the wider it's open, the larger the angle. The closest together those blades are, the smaller the angle. So the angle is the thing in between. Let's talk about how to name an angle so we can know how to write it down on paper. How to name an angle. This one's how to draw. How to name an angle for this guy right here. There's only one angle here, so I can use the angle symbol and say just the vertex name. That's one way to do it. But usually you're going to have a little more complicated of a diagram, and we name it with 3 letters, and the vertex has to be in the middle. So one way to name this angle would be BAC, and you could also go the other way, CAB. Now let's look at a different diagram. Three rays with the same initial point. That initial point is D. This will be E, this will be F, and this will be G. Now for this one, you cannot call this angle D because there are actually 3 angles that have D as a vertex. Now the first one I'm seeing is this guy right here. Now I can name this 2 different things, but D has to be in the middle. It's EDF or FDE. Angle, use the symbol, EDF or angle FDE. Another angle is right here, also has D as a vertex. And again, we can name that angle 2 different ways. You're probably already ahead of me. Angle FDG or angle GDF. And you might have thought for a second there those were the only 2 angles, but there's a third. This guy, the big one. So E, D, G, or GDE. And that's how you name angles. Not good to use angle D. You don't want to do that one. No, 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 no. Because you don't know which one they're talking about if you say angle D. Make a note though. You notice the D is in the middle for all of them? That's because it's the vertex. How to measure angles. So you're going to use something called a protractor. It's this thing. Now, you probably don't have one of these in your hand right now like I do. I'll just make a little diagram right here, make a little picture of it. People get this mixed up with a compass. The compass is the thing you draw circles with, it twirls. So I'm going to demonstrate how to measure. Got to draw one first. Alright, so to measure this, we are going to put this, one of the sides, doesn't matter which, and your angle may not be sitting all nice like this, but you put that side and you line it up on this bottom line of your protractor. Not the bottom edge, but the actual bottom line. Your vertex goes in the bullseye right there. There it is. I'm going to take my angle that I drew, and I'm going to extend that line out a bit. Normally I would just use a pencil, but for video I'll make it with a marker. Line it up, and you can see my yellow line is landing somewhere right in here. It's really close to 40, but not quite 40, not the 140, but this 40, of course, right where I have words, right there. So I'm going to call that, I don't know, 39 degrees. Okay, so I'm going to do another one down here so I won't run into the words. Alright, so my angle is right here. Now to measure that with this protractor, you take your vertex and you put it on the bullseye. You line up the bottom of your angle, or one of the sides of your angle, with the bottom of the protractor. And then you look and see where that's crossing. Now this time I know it's bigger than 90, so I'm not going to use the bottom row, I'm going to use the top row. So this looks like 140, this is looking like about 145, 146. 146 degrees. Okay, before I move off this page, let's pretend that, I'm not pretending, I'm going to call this angle S, and I'm going to call this one angle R, because we have a little notation here. Like above here I was talking about how to name an angle. But when you're talking about the measure of an angle, you do something differently. So here, if I want to say that, if I want to write down that the measure of angle S is 39 degrees, instead of writing down all those words, you use the little m, a small case m for measure of angle S equals 39 degrees. And on this one, I would say that the measure of angle R equals 146 degrees. Measure, that little m means you're talking about the size of the thing. That equals 39. If we wanted to just talk about the name of the angle is angle S. Its size, its measurement, is 39 degrees. That's just a little notation thing. We classify angles by their sizes. The first one, just draw a little angle like that, and it's called an acute angle. Acute angles are less than 90 degrees. Right angles, they look like corners, but unless you're told it's a right angle or you have a little square symbol in the corner there, that's the symbol for telling you it's a right angle. They equal 90 degrees, not 91, not 89, they equal 90 degrees. Making a big angle, the angle starts there and goes there. This is called an obtuse angle. Obtuse angles are between 90 and 180. They don't equal 90 degrees and 180 degrees. They're between them. And that doesn't just mean 91. It means like 90.1, 179.9. Those angles are called obtuse angles. And the last one looks like this. Really, this is also the diagram for opposite rays. If I have a ray that starts here and goes this direction, and then I have one that goes completely opposite of that, my line doesn't look straight, but let's pretend it is. This is a straight angle. There's a couple ways of looking at it. It's opposite rays. It also looks like a line with a dot on it. This is called a straight angle. Straight angles equal 180 degrees. Now, if you're in my geometry class, this is the part where I try, I embarrass myself. But here's how you remember it. Obtuse. A cute little angle. You're welcome. All right, let's do some practice problems. I'm going to show you 8 problems. Check yourself and see if you get these right. Choose the wrong name for this angle. Okay, this one might be a little tricky because I forgot to tell you that if they put a little number here at the vertex, you're allowed to use that for a name. That's okay. But if you look at your choices, the one that really sticks out as being the most wrong is angle A, because A is over here on a ray. It's not the vertex. ABC is working, everything else is working. So the wrong name here is C. Okay, the wrong name here is going to be angle H. So B is the wrong answer for this one. Now, I know this is a video, so you can't really use a protractor. You probably don't have one. I want you to estimate the size of this angle based on what you know about the different kinds of angles I talked about in the notes just a minute ago. This is definitely an obtuse angle. 90 degrees would be right here, so it's going beyond 90 degrees. So anything that's less than 90 degrees is not going to work here for us, so it's not going to be this. Then it's a matter of how much more than 90 degrees. Well, 180 would be a straight line, so I'm thinking the 165 and the 150 are too big. I'm going with the 130 on this one. Okay, how big do you think this angle is? It's less than 90 degrees. I can see that because 90 degrees would be going straight up here towards that 4. So anything that is bigger than 90 degrees is not an answer. So D is not an answer and C is not an answer. 85 would be really close to 90 degrees. This isn't really close to it. I'm going with A, 50. In class, if you're tested on this, they're going to give you a protractor. Classify the angle. Oh, I bet you got it. That is a cute little angle. It's such a cute little angle. Do it again. That is a big angle. It's between 90 and 180, so that is an obtuse angle. How you doing so far? I'll bet you're acing this. Obtuse. I know, it looks like a line. It doesn't even look like an angle. So remember what that is? That is a straight angle. How'd you do on this? Hey, thanks for playing. Here is your next lesson. Bye. I'd like to take a moment to talk about congruent versus equal, because this is an important concept in geometry and it's confusing. We use the word congruent a lot. We use the word equal kind of like normal because it's a math class, but congruent is a word that's pretty much just used in geometry. They are almost the same, but there's some subtle differences. If two things are the same size but are actually two different things, we say that they are congruent. Let's not think about this in math. Think about this in the real world. If you have two shirts that are the same size, they're going to be congruent, but they're two separate things. You might have a red shirt and you might have a blue shirt. They're two separate things, but they're the same size. So we say they're congruent. The reason this is a little bit weird, because we're used to doing this sort of thing in math. So in math, we can say something like this. 10 divided by 5 equals 2. Not congruent, but they actually equal. And that is because 10 over 5 is just another way to write a 2. They are actually the same thing. 10 over 5 is 2. It's not like having two different shirts. They are the same thing. The symbols for congruent is a little bit different. Let's go back to the shirts. A red shirt of a size medium compared to a blue shirt of size medium. We would say red shirt, size M, and blue shirt, size M, are not equal. They're two different shirts, but they are congruent. So the symbol we use for that starts out as an equal sign, but it has this little squiggly on the top. It's kind of like a sideways S. This is the congruent symbol. They're two separate things, but they are the same size. We were just talking about angles in the last lesson, so I am going to talk about congruent angles right now. We're going to be talking about congruent things for the rest of the class, but let's draw some angles. I've got angle H sitting over here. I'm going to keep them separate so I only need one letter. So there's angle H. And I'm going to tell you the size of angle H is 50 degrees. We're going to go with that. We're not measuring it. And this angle clearly looks to be a different size, but I'm not drawing anything to scale. Get used to it. That's how we roll in geometry. When you teach it, you'll understand. I'm going to say that's 50 degrees too. Okay, so here's what we know. The measure of angle H equals 50 degrees. The measure of angle K also equals 50 degrees. Since these two measures are equal, we can write this. The measure of angle H equals the measure of angle K. I'm not talking about the two separate angles. I'm talking about their size. 50, 50. 50 degrees is 50 degrees, and they both equal 50 degrees. Because this is true, I can now say, using their names, that angle H is congruent to angle K. Oh, heck yeah, I know that's super subtle. I mean, you'll get used to it, I promise. So, to put it into words, measures are equal, angles by name are congruent. Gosh, I hope that helps, but I expect that you have questions, so leave them down in the comments. This lesson is about angle addition. We already did segment addition. Let me remind you of that, and I'll also put a link up here. Remember. And with segment addition, we did something like this. You'd have a little chunk, and then we would pop another guy next to it. And the question was, like, how long were these going to be? Like, if I tell you this one is 3, and then this one is 7, then the length of the entire thing would be 10. You would just add those together. Angle addition is the same idea. So if you wanted to know how big this entire angle was, all we got to do is add those two together. 30 plus 100 would be 130 degrees. All right, let's try something that is a little bit more involved. And so I'm going to draw a diagram that's a little bit more complicated. You're drawing with me, I hope, because I wanted you to build a notebook that you could use as a supplement to your geometry class, or if you're just refreshing yourself on how geometry works with my videos, you have a little notebook. So for whichever test you're studying for. So I'm going to call this 60. I'm going to call this one 40. No, nothing's drawn to scale. Just go with it. In geometry, nothing's ever drawn to scale. We tried, but I kind of just did it. So the question is how big is maybe this angle? How big is that one? And so you would just add those two together. 40 plus 25 is 65. And then somebody might want to know, well, how big is the whole thing? What if you added all of them together? 60 and 40 is 100 plus 125, so this whole thing would be 125 degrees. So the idea of angle addition is actually really simple, but the problems themselves are not. So I'm going to switch over to the computer and show you some examples, and we're going to do some practices too with some little more complicated problems. In the beginning of geometry, you're going to see problems like this, and it's going to feel like you are trying to do a whole different language, because you know it, yeah, you kind of are. Find the measure of angle UCB if the measure of DCB equals 174 and the measure of angle DCU equals 54. So first thing I always do is mark up my diagrams. So, and I have colored pencils and highlighters all the time. So what I've done here is I've taken the information that they've given me. DCB is 174. Well, DCB is the entire angle. So that's the 174. DCU is this angle right here. I've done it in pink. That's 54. And we want to know what UCB is. UCB, this green angle, is not the 174, but the part of the angle that when you add it to 54 is going to give you 174. Now, you're probably doing it in your head, but you need to know how to write this up because they're not always going to be like this. So we go ahead, do 174 minus 54, and we come up with the answer of 120. All right, I would like you to try to do this one on your own, and I'll be right back with the answer. All right, it's a very similar problem than the one we just did. Let's fill it in. All right, hope you got that. This one I want to do for you. This is where it starts to get a little bit gnarly. We're going to be bringing algebra into geometry. All right, FGH is the entire angle. FGH is the whole thing, and the whole thing is 160 degrees. FGC is this guy right here. It's x plus 114. And the other part of that angle is x plus 54. Remember, this is angle addition, very much like segment addition. You add two little pieces together and make it equal to the whole thing. So that's the setup. Now we need to just forget it. The geometry is done once you have this part written. Now you're going to do algebra. We're going to start by combining like terms, putting the x's together and putting the numbers together. Now we subtract 168 on both sides. We end up with 2x equals -8 and x equals -4. That is the correct answer, but sometimes when you get negative answers in geometry, it's kind of unnerving. So watch me check this. If x is -4, that means this would be a -4. And when you put a -4 with a 114, you get 110. When I put a -4 with a 54, I get a 50. When I add these two things together, you get the 160, which is what you're supposed to have. Try this one. All right, here is the solution. Very fast. That went by. You might need to pause this and take a look at it. And the answer is x equals 3. If you didn't get that, go back and look at your work and compare it to mine and see if you can find your mistake. Because you learn from mistakes. You don't learn from getting things right. That's fun and all, but that's not how we learn. All right, I'm going to do this one. It's very similar to what we did before, except after we find the x, we're going to have to plug it in to find the actual angle. In this case, we're looking for the size of angle ABU. All right, ABC, which is the whole thing, is 13x minus 6. ABU as an algebra expression is 4x plus 22. That's where we're going to plug the x in when we're done. And UBC is 80. Again, the setup is the same. Add the two little pieces together and set it equal to the whole thing. I did that here. I'm going to combine the 22 and the 80 and get 102. So now I have an equation with variables on both sides. The way I like to do this is to subtract the smaller variable. And so then I'm going to add 6 to both sides. We end up with 9x equals 108. Divide 108 by 9, you get x equals 12. Now, one of the most common dumb mistakes you'll make in geometry is you're going to feel like you're done right here when they really want you to plug it in. So Make some room. We have to take this x equals 12 and we need to plug it into 4x plus 22. Easy math, easy math. Answer is 70 degrees. All right, here comes one like this with different numbers for you to try. And here comes the full solution. Okay, I lied. It's not the full solution. It's just to get to the x. Check your work and see if you got x equals 10. We're not finished yet, but you have to have this part right. And I need to make some room. So once you know that x is 10, how did you do on these? If you have questions, which I totally expect, drop them in the comments down below. Today I'm going to talk about angle pairs. These are the angle pairs we're going to be going over today. I'm going to draw them all out. Let's start by making a right angle. You know it's a right angle if it's marked with that, or they tell you it's a right angle in text, but usually you're going to see it like that. And these are lines, so they're going forever. And I'm going to throw in array. An array has an initial point and goes in forever in one direction, but I don't want to split this exactly in half. I'm just kind of putting it in here. Looks like this. I'm going to add some points. P, Q, S, and R. We've got several angles on here that I need to talk about, so I am going to color code. I've got an angle here. I have another angle on this side. So there's two angles right there. But the entire, if I were to put both of those together, like an angle addition, if we added those together, even if we don't know exactly what they are, we do know what they add up to. These two angles together are going to be 90 degrees. Agreed? So now let's put some notation in here. Once you have the big idea of it, the notation is like you're learning a new language, and that's confusing. If I'm talking about the blue angle, I like to color code my notes a lot. It makes it easier to understand diagrams. And if we added it to this, what is that, pink angle? We know that that's going to equal 90 degrees. So now let me put the notation in here. The blue angle is P, Q, R. Q is the vertex of that angle right here. So you have to put that in the middle. The notation for measurement is to put a small case m, put an angle symbol, P, Q, R. The pink angle. I could have started with here and done R, Q, S too, talking about that blue angle. The P and the R can be switched, but the Q has to be in the middle. So for this pink angle, you can go RQS, or you can say SQR. I'll start with R. Plus the measure of angle RQS equals 90 degrees. Now this is in text. Obviously, if you're reading a book, it's not going to be highlighted like that, but you could highlight it. So if these two angles add up to 90 degrees, we call them complementary angles. Make sure you spell it right. If you use an I, you're talking about giving someone a compliment. But if you're talking about two things that complete each other, you complete me. It's not exactly like that either. Complementary. Please be nice if I spell things wrong. Complementary. I always do make spelling mistakes. Oh, a point about complementary angles is they don't need to be next to each other like this. This is the easiest way to teach it, but complementary angles could be split apart. So if I had an angle over here that was 30 degrees, and this guy, another one over here, let's just say 60 degrees. These two would also be called complementary angles because 30 plus 60 is 90. They don't need to be right next to each other. They don't have to share a side. We'll talk about that, what that means in a second. That's adjacent if that's the case. But these are complementary angles too. All right, let's go to supplementary. To draw supplementary angles, again, they don't have to be right next to each other, but this is the easiest way to think about it. So you start by drawing a straight angle, which looks like a straight line, but if we were going to measure it, it would be 180 degrees. Then you add a ray. Put it anywhere you want to. It can point in any direction. And then we have a smaller angle here. We have a medium-sized angle here. And then we do have the whole thing, which we know is the yellow angle is 180 degrees. I gotta put some points on here so we can fill out the notation. We'll put an A here. Let's put a B there, a C here, and a D up there. So now I'm going to just fill it out with the notation. You don't need to know what the angles actually are to know that they are supplementary. If you see a straight line in a geometry diagram, you can assume it's a straight line, and that means you're making a 180 degree angle if you're talking about angles. So we have, again, we have a medium plus the teeniest angle, and we know that's going to equal 180 degrees. These are called supplementary angles, but I'm going to put the terminology on that because we're still probably learning how that works. Okay, the blue angle, B is the vertex. So you can go A, B, D, or you can say D, B, A. Most people are probably going to go like this. So you put the small case m because we're talking about the measure of it. Adds up to 180 degrees. And the angle is A, B, D. The measure of angle D, B, C, these two together add up to 180 degrees. Now, this little notation means measurement. I should have done it on the first one, but I'll do it here. If we're going to just talk about the angles by name, we would say angle without the little m, just the angle sign, ABD, and angle DBC are supplementary. And I could have said the same thing up here. I could have said angle, not with the little m's, I could have wrote down angle PQR and angle RQS are complementary. That's how you talk about them by name. But if you're talking about how big they are, you put the little m on there. So we're talking about when numbers come in. Now, people do get these confused, and you do need to memorize them. C to S, put them in alphabetical order, 90, 180. Put them in numerical order, and they match up that way. A visual of what I just said is that I would go C, 90 degrees. I'd put this on the board, S, 180. That's how I memorized them, and that's how my students in class memorized it. Adjacent angles are next to each other. Adjacent, if you live in a house, there's a house next to you. If you live in an apartment, there's an apartment next to you. They are adjacent. Adjacent neighbors live next to each other. Adjacent angles live next to each other too. They share a side. If I were going to draw adjacent angles and I didn't want to make them, complementary or supplementary or something, it would just be something that kind of looks like this. These are adjacent angles and they share this side. So complementary angles that are right next to each other can be adjacent. Supplementary angles that are right next to each other can be adjacent as well. Vertical angles. Vertical. Can't lie. These are one of my favorites. Okay, vertical angles. The visual probably explains it more so than words. Vertical angles are across from each other, and what I mean by that is that these two angles are vertical. They're vertically across from each other, and that, if you understand the word vertical, that makes sense because they're up and down, right? But of course in math it has to be a little more confusing. These two angles are also vertical angles, even though they're across from each other horizontally. So vertical angles are across from each other. You can always go like this too. And now these guys are vertical and these guys are horizontal. Vertical angles are across from each other and are congruent. That's the right word. But means the same size. Oopsie. Same size. All right, so if this right here was 60 degrees, this one would be 60 degrees. Now, if you think ahead here a little bit, if you look at this one, this 60-degree angle is making a straight line with this angle. So we know they're supplementary, and that's going to add up to 180. So this one must be 120. Since these two are equal, this would be 120. We have done complementary, supplementary, adjacent, and vertical. We've got one more term that I need to define for you. And it's going to be kind of a combination of two things. And that's called linear pair. And this is going to feel repetitive, but it is a term you have to know. The root of linear pair is this right here, where it says line. So a linear pair is two angles that are adjacent and supplementary. Okay, so you already drew them. I just didn't tell you that that also means linear pair. I'm going to just draw it a little different. So you see two angles that look like this? This is a linear pair because they make a straight line when you add them together. I'm going to put this one here plus that one there. They make a linear pair because they make this straight line, which means it adds up to 180. I know. It's just another phrase for it. Let's put some points in here. Because you got to learn the language. So which letters should we use? M, N, P. I like Q. All right, so the notation here is that I'm not going to do the measurements. I'm talking about the angles. Angle M, N, Q. M, N, Q. And angle P, N, Q are a linear pair. I forgot the I. Squish it in. All right, let's head over to the computer and do some problems. You will be checked on some vocabulary. So something like this, pretty straightforward. Just name the relationship when you look at this diagram. Are you talking about complementary, linear pair, vertical, or adjacent? You have to choose the best answer. Notice supplementary is not in there. That's because I don't want you to get that confused with the correct answer, which is linear pair. If you say adjacent, adjacent is not false. It's just not the best answer because linear pair is better. All right, look at that diagram. Choose the best answer: complementary, linear pair, vertical, or adjacent. Some people are going to want to say complementary, I think, but there's no indication here that that's a right angle. So the best we can say is that they share a side, so the correct answer is adjacent. Complementary, linear pair, vertical, or adjacent. You see the right angle, so there is your big clue. It's not a linear pair. They're not vertical. They're not across from each other. They are adjacent, but the best answer is complementary. All right, complementary, linear pair, vertical, or adjacent. That's vertical. All right, now we get to do some math. Now, even if you forget the vocabulary, if you do when you get quizzed on the vocab, you're going to get them wrong, but you can still get the math right if you remember what things are when you look at the diagram. You're supposed to find the measure of angle B. Well, angle B is right next to an angle that says 78 degrees, and the two of them together make a straight line. So they will add up to 180 degrees. Just subtract the 78 from 180, and we get an answer of 102. B is vertical to 40. Pretty easy. There's not much math to do. Vertical angles are congruent, which means they have the same measure. So we've got 40 degrees. Find the measure of angle B. Angle B and 68 degrees add up to 90 degrees. So we're just going to subtract, and we get 22 degrees. I threw this one in here because this is where problems like this will usually show up in a class, on a test, or a quiz. But these are not angle pairs. What's going on here is I have 3 angles, and one of them is missing, and you're supposed to figure it out. People are going to assume that you know that an entire circle is 360. That's how you approach this. So B plus 38 plus the 298 is supposed to equal 360. So let's combine these two numbers on this side. B plus 336 equals 360. Subtract the 336 from both sides, and we get 24, and that is the correct answer. All right, these are going to jump into being something kind of algebraically pretty quickly. Find the value of x. You have to use what you know about geometry to set up an equation. Well, what I've got here are 2 angles that when you put them together add up to a straight line. So if you added those 2 together, you would get 180. There's the equation. That's the end of the geometry. Now you have to be able to do algebra. Let's subtract 64 from both sides, and we get 4x equals 116. Divide the 116 by 4, we get x equals 29. These 2 angles, you have to know the relationship between them. They're the only 2 angles you've got in this whole diagram. Something's got to go on here. Process of elimination, they're not right next to each other, so adding them together doesn't make any sense. You won't know what they would equal. You can't say they would add up to equal anything, but they're vertical angles, and vertical angles are congruent, which means they are equal. Right here, vertical angles. That means the 48 equals the 5x plus 3. So that's the equation you start with. End of the geometry. Now you do the algebra. You subtract 3 from both sides. You get 5x equals 45. And divide by 5. We get x equals 9. These 2 angles are adjacent. They share a side. Their 90-degree mark is right here, which means they're complementary, which means they add up to 90 degrees. So I'm not going to make them equal to each other this time. I'm going to add them together and set it equal to 90 degrees. All right, now we need to combine these numbers. We get 5x plus 50 equals 90. Subtract the 50 from both sides, and then divide by 5. We get x equals 8. I hope you got that. Try this one. this is all going to add up to be one big circle. That's going to be 360. So if I add all those things together, now we need to combine some terms here and see what we got. Well, we got the positive 29 here and the minus 29 there, and they're on the same side of the equation, so they cancel each other out. You have 5x and an x. That is 6x, and that equals 360. Divide both sides by 6. X equals 60. Now, if they wanted you to actually figure out what any of these angles were, you would take your x and plug it back in. I didn't do that on this. We're going to talk about segment bisectors today. In biology class, have you ever dissected a frog? Dissecting means to cut it up into pieces. So bisecting means to cut it up into 2 pieces. But they are equal pieces. 2 equal pieces. The bisector is the thing that does that. So it can be a point it can be a line, it can be a ray, it can be a segment, anything that takes another segment and cuts it in half. And again, this needs to be a segment, not a line, because lines go forever in 2 directions. You can't really cut them in half. Ooh, no, segment. I drew what I was saying. Okay, so if you have a segment and there's a point in the middle, they usually will label it something like M, but in this case, I'm going to draw a line that goes through it like that. It doesn't have to be straight, doesn't have to be perpendicular. That's what I'm saying. You probably expected me to go straight up and down. That's called a perpendicular bisector. We'll talk about those another time. But anything that would cut this thing in half, you notice I didn't measure it, I just put 2 congruent marks on it. This half is equal to that half. So if you, for instance, had something and it wasn't in the middle, put a point there. You could put 1 mark on here, but a little 2 hashes here. This would be not congruent segments. All right, so this is a segment bisector. We're going to do a bunch of problems with this. The notes on this are pretty easy, but the problems can be really difficult. This one is almost like a true and false question. Is M the midpoint of AB? Well, they're telling you that the whole length of it is 35. And they're telling you that this piece is 15. So you just pretty much need to figure out what this piece is. If it's a midpoint, then this would be 15 too. And somebody in their head is doing it right now, and I get it. But just in case you're not following, I'm going to show you the math. I don't know what that is. I take 35, subtract 15, and I get 20, which means this piece is 20, and 20 and 15 don't equal. So the answer is no. This is not a midpoint. Looks like it is. You can't go by that. The diagrams are all going to look lovely and wonderful. Everything's going to look great, but you can't assume it unless you're told. M is the midpoint of CE. They are straight up telling us that that is true right now, and you are supposed to solve for X. If you want to try to do this on your own, pause. Otherwise, I'm moving forward for the solution. If it is a midpoint, it means that the 2 pieces are equal to each other. So I'm just going to set up the equation. 77 equals 7 plus 5x. I subtracted 7 from both sides. I did it in my head. I get 70 equals 5x. Divide both sides by 5. X equals 14. G is the midpoint of FH. So that means these 2 pieces are equal to each other, and we set that up and we're going to solve. Once you have the equation set up, that's the end of the geometry. Then it becomes a matter of knowing how to do the algebra. In this case, it's a variable on both sides. The way I like to do these is I like to subtract the smaller variable from the larger one. So I'm going to take 4x away from both sides. And when I do that, I end up with 8x minus 4x is 4x, minus 15 comes down, equals, these 2 are going to cancel out, and you're just left with the minus 3 on this side. Add 15 to both sides now. And we get negative 3 plus 15 is 12. 4x equals 12. X equals 3. This one's a little tricky, but if you think you can do it, pause and give it a go. K is the midpoint of JL. You have to be told that. So once we know that these two pieces are equal to each other. And the whole thing now is 12 plus 8x. There's probably more than one way to do this. The way I'm going to do it is I'm going to try to point out the obvious. This side is congruent to this side, which means I can say that both of these two things are the same size, and when you add them together, they're going to equal this. So I'm just going to copy 8 plus 3x over here again. I have two of the same thing, so I'm going to just write it as 2 times 8 plus 3x equals 12 plus 8x. This is distributive property, so we have to multiply that 2 through. We get 16 plus 6x. 2 times 8 is the 16. 2 times 3x is 6x. I didn't do anything on this side, so I just copied it down. Now, my preference when I have variables on both sides of an equation is to subtract the smaller one from the larger one. So I'm going to end up with, this is going to cancel, so just the 16 is left on this side. So I end up with 16 equals 12 plus 8x minus 6x is 2x. Take the 12 away from both sides, and we end up with 4 equals 2x, and we get x equals 2. What we've got here is a line segment with a midpoint on it. I constructed this, so I know that's a midpoint. Let me show you the distance from A to M and the distance from M to B, and they are the same. That makes M the midpoint. Let's look at the actual coordinates. A is 1, 2, and B is 11, 6. And so this will be how a problem will set up. They'll just give you some points. You may not even get a picture, but you'll see some points, and they want to know what the coordinates of the midpoint are. I'd like you to see if you can figure it out. So what I'm going to do here is I'm going to take this guy and drag him underneath here. Now let's add up the x coordinates, 11 and 1, and we get a 12. Let's add up the y coordinates, 6 and 2, we get an 8. So we have coordinates x 12, y 8. Is that the midpoint? Well, no, it's way over here. So you want the midpoint to be here. The midpoint's halfway. The midpoint is 6, 4. Compare that to the 12, 8. What did they do? We added the x's together and divided by 2. We added the y's together and divided by 2. So that should help you understand the actual midpoint formula, which is this. x1 plus x2, that's the first x and that's the second x. Doesn't really matter, you can switch them up because you're adding them. Divided by 2, and then we're going to do the same thing with the y's. y1 plus y2 divided by 2. And you understand that looks a little complicated with all these little subscripts, but that's why I wanted to work this out for you ahead of time so you could see what you were doing. Add the x's together, divide by 2. Add the y's together, divide by 2. This is awesome for people who like formulas, but if you're a little formula adverse, there's another way to do this, and since we're in geometry, I kind of like this other method too. So I'm going to show that to you right now. All right, here is the same problem, the same endpoints. So we're going to approach it a little bit differently. If I go across the bottom here, I want to count the number of boxes that I have right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, awesome. Halfway would be right here after 5. So you have 5 on one side, 5 on the other, so that's halfway. So the midpoint must have that as the x coordinate, and that means it's right there, whatever that point is. So let's figure out the coordinates for this point right here. Well, the x coordinate is, now remember, these are just counting the boxes. You got to go back to the graph and look at what the actual coordinate is. The x coordinate is 6, and the y coordinate is 4. So there's the midpoint again. Did it a different way. Part of the reason I'm showing you this is a little intro to something in a lesson that's coming up called Partitioning Segments. More on that another time. So I've gone over this 2 different ways. The one we just did was counting boxes. I don't know an official name for that. It's just something that I like. And then this way, to introduce you to the formula, which is what you're normally going to see in a math class. I just want you to know you always have another way of being able to find it, and that would be the counting boxes. All right, let's look at some problems. Find the midpoint of the line segment with the given endpoints. And I think I'm going to probably use the formula because it's kind of easy. Add the x's together. x1 is 9, x2 is 7. You're going to add the y's together, and we'll divide those by 2 as well. y1 is 8, y2 is 10. So we pop everything into the formula. To simplify this, 9 plus 7 is 16 divided by 2, so that would be 8. 18 divided by 2 would be 9, and there's our midpoint. The formula rocks if you really get it. It's just that when you see it on paper, it looks very intimidating. The process is the same, but the numbers we're working with are going to be a little bit more challenging because we have negative numbers in here. You're still going to do the same thing. Add the x's together, negative 7 plus 5 over 2. Add the y's together, negative 4 plus negative 8 over 2. Negative 7 plus 5 is negative 2. Negative 4 plus negative 8 is negative 12. And we're going to divide both of those by 2, so we end up with negative 1 and negative 6. You're going to take the negative 3 and the negative 6, put those together and divide by 2. You're going to take the 3 and the negative 2, those are the y's, put those together and divide by 2. Those are fractions. You can put them in as decimals, and you have to go with your teacher. But these fractions are in Lowest terms, and they're fine. This is the most difficult type of problem that comes in along with this midpoint. And the difference, it's like the midpoint questions are so easy, then all of a sudden this little sucker shows up, and everybody just like can't figure out how to even start. Given the midpoint and one endpoint, find the other endpoint. I always draw a picture for these. I have the endpoint 3, negative 1. I'm not putting this on graph paper. I'm just drawing myself a little helping picture. I know that the middle is negative 2 and 3. And what I don't know is what the other endpoint was that they used to come up with this answer. So I do know that these are my x coordinates. These two things added together and divided by 2 came up with an answer of negative 2. All right, so that's one little equation I need to solve. Start by multiplying that by 2 to cancel that fraction. Then if you multiply one side by 2, you got to multiply the other side by 2. We end up with 3 plus x equals negative 4. And then subtracting 3 from both sides, we get x equals negative 7. So this x will be negative 7. Now we got to do the same thing for the y's. This negative 1 plus this y divided by 2 equals 3. Set up the little equation, do the same thing, multiply both sides by 2 to cancel the fraction. We end up with negative 1 plus y equals 6, and y equals 7. So our other endpoint was negative 7 and positive 7. Hey, Future Tammy here, and I was editing this video and I thought we need to do this problem again, but put it on graph paper, because not everybody's going to dig the algebra. So watch this. I'm going to graph the endpoint first. There's the 3, negative 1 endpoint. Then I'm going to graph the midpoint, and that is negative 2, 3. Then draw a ray. You want it to start at the endpoint and go through the midpoint. Now we're going to do a little counting boxes action, because I like counting boxes. So I'm going to go from the red point, from the endpoint up to the midpoint. I have to go 5 units this way. Don't get this mixed up with slope. I'm not doing slope because this would be a negative 5 on slope. I'm just counting boxes to see how to do that, how to find the other endpoint. So 5 boxes in this direction. 1, 2, 3, 4, 5. And then 4 boxes up. And then do it again. Follow that pattern, because we know about those 2 points. We're looking for some missing third point, and we're going to find it by going 5 boxes this direction and 4 boxes up, and boom, there's our other endpoint. And we didn't have to do any algebra. All we have to do now is try to come up with the coordinates for that. So let's see what that would be. The x coordinate would be right here, so that's going to be negative 7. And the y coordinate would be here. So the actual coordinates are -7 and +7, which is what we got when we did the algebra, right? Yeah, I know. I like this method better too. Again, do not get what I just did mixed up with slope, but if you understand it, there would be a difference here. Like if you wanted to use this for slope, one of those numbers would be negative, the 4 or the 5. In the comments, tell me if you know that answer. Hey, welcome to your next geometry lesson, where today we're going to do partitioning. Not every geometry teacher does this. You need to check with yours. In my district, the honors level geometry does partitioning and the regular one doesn't. Let's jump into it. I want to do a little bit of review to kind of warm you up to it. It's probably been a minute since you worked with ratios. This is a ratio. The ratio is read 1 to 3. That means there are 4 parts. You are going to split something up so that you have 1 part compared to 3 parts. So let's put that something on here, and I have a line segment. I have some points. The points are not what I'm looking at. What I'm looking at are the sections. I'm going to be looking for a point that divides this up so that it is 1 part to 3 parts. That point would be right here. 1 part compared to 3 parts. Same numbers, but the ratio is different. Now it's 3 to 1. We still have 4 parts total, and we're going to find the point. So it's 3 parts first and then 1 part. So that would be this point right here. 3 parts compared to 1 part. 2 to 3. How many parts is that total? Well, that's going to be 5. 2 plus 3 is 5 parts. And we are looking for the point that divides this line so that we have 2 parts compared to 3 parts. That would be right here, 2 parts, 3 parts. Now I have 2 points here, 2, 0, and 8, 0. The line between them is a line segment. How long is that? It is 6 units long. You can also figure out how long something is by subtracting. I am going to be dividing this up into a 1 to 1 ratio. 1 to 1 means it's going to be 2 parts. 1 plus 1 is 2. So there are my 2 parts. 1 part to 1 part means we are choosing the one in the middle. That's our point that divides this up into a 1 to 1 ratio. That's point P, and in this diagram, that would be the coordinates 5, 0. When you come up with the coordinates, you got to go back to the original coordinate grid to figure out what those numbers are. I'm starting with this one on purpose to connect this to the last lesson, which was midpoint. When you find a midpoint of a line, you are doing this. You are splitting that line up into a 1 to 1 ratio. But now with partitioning, it isn't just going to be 2 parts. We're going to have many more parts. So let's do it again. Now we're going to take the same line and we're going to partition it differently so that it's in a 2 to 1 ratio. We still have 6 units total, but 2 to 1 means we need to have 3 parts. 6 divided by 3 is 2, so each one of these little parts needs to be 2 units long. And we want to find the point that splits it in 2 parts to 1 part. Well, here's the first part. There it is, right here. This is it. 2 parts to 1 part. The coordinates of that point, 6, 0. Let's make this a little bit more realistic for geometry or algebra class or wherever it is that you're being asked to do this. We're partitioning line segment AB at a point P so that it's in a 3 to 1 ratio. I haven't talked about it. These are referred to as directed line segments. It matters where you start when you're dividing these things up into these ratios. AB means you're starting at A and going to B. Now, it can be very complicated on a slanting line, and there's going to be teachers who like to use formulas and stuff. I don't. I really like doing this on graph paper. In a minute, I'll show you how to do it with just algebra, so you don't have to use graph paper. But for geometry, I hope that you have some graph paper. What I do when I show it to my kids is we make a horizontal line, like if we were making a triangle, but we don't make the whole triangle. Just make this flat line that goes from A, which is -5 on the x-coordinate, all the way up to B, which would be 7. How long is that line? You have to figure that out first. I know I want a 3 to 1 ratio, so I'm going to be splitting it into 4 parts. Well, what am I splitting into 4 parts? Let's count the sections. 6, 7, 8, 9, 10, 11, 12. Okay, so this line is 12. 4 parts means that each one of these is going to have to be 3 long. So 1, 2, 3, put a point. 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 So those are my helping points And which one of these is going to split me up into a 3-to-1 ratio? 1, 2, 3. It's this bad boy right here. And so that point on the slanty line would be right here. And that's the point P. That's it. All you have left to do now is figure out what the coordinates for that point are. This is the helping line I use with my students so that they can find that point real easy. So let's get the coordinates of this point. Well, remember, this is not the coordinates, this 1, 2, 3, 4, 2, 12. This is just me counting the boxes. The coordinates have to go back to the original grid. So the x coordinate is down here. That's right here. That is the number 4. The y coordinate, go back to the y-axis, is 6. So the coordinates of this point are 4, 6. It takes practice. This is not super simple. Let's do another one. The process I'm going to follow is the same, but what's weird about this one is the language of the question. Find the coordinate of the point P that is 3/4 of the way along the directed line segment from C to D, 3/4. Fractions work a little bit differently. In this fraction, they're telling you that the total number of parts is 4, and you want 3 of them from C to D. First thing I do is I draw my horizontal line because that's easier to work with than slanting lines to figure out these distances. I know I need to have 4 parts total because it says 3/4. This whole thing is 8 long, sweet, because 8 divided by 4 is 2, which means I'm going to put a point here, 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 and here. So I just made points every 2 units. The one that's going to get me 3/4 of the way is 1, 2, 3, right here. All right, that's me on the flat line. Now I need to move this up to the slanty line. So the point I'm looking for is this one. That's point P. We need to get the coordinates of that. This is the origin, so we are right at x equals 0 and y equals 1. This is the directed line segment. This point splits it 3/4 of the way. I promised you I'd show you how to do this without graph paper, although I'm going to tell you, I think if you ever do one of these things, you really need to just go find some graph paper. But for those of you who dig algebra way more than graphing, here it is. What are the coordinates of the point on the directed line segment from -5, 3 to 7, 7 that partitions the segment into a ratio of 3-to-1? Yes, there will be teachers who give you formulas for it. I'd much rather just figure out how to do this. I have some segment. I haven't graphed the points or anything. I'm just going to use the coordinates and figure this out. 3-to-1 ratio means we're going to split that line into 4 parts. Let's look at the x's first. The first x is -5 and the second x is 7. So x's go from -5 to 7. Here's -5 and here's 7. This is not a number line. This is not even going to be any kind of accurate at all. I'm just making myself a helping line so I can figure out what I'm doing with these parts. How far is that whole thing? Well, to go from -5 to 7, you go from -5 to 0. That's 5 steps. And then from 0 to 7, you go 7 more steps. 5 and 7 is 12. I'm going to take the whole length of that, which is 12. I'm going to divide it into 4 parts, which means each one of my parts needs to be 3 long. Go 3 towards the 7. 3 units positive would be -2. Now I'm going to take 3 more steps, and I would land at a +1. -2 plus 3 is 1. Now it seems a little easier. 1 plus 3 is 4, and 4 plus 3 is 7. So these are the x coordinates of the points if we were looking at a picture, which we decided not to draw, so that's how it looks now. Again, this is a helping line. This isn't any kind of accurate. The ratio is 3-to-1. So which one of these points is going to split me 3-to-1? 3-to-1, 2, 3, right here. This is going to be the x coordinate for our answer. We don't know the y coordinate. We just know the x coordinate right now. We're done with that. We're going to repeat that process for the y coordinates. Clear off my space. My y's are going from 3 to 7. Well, how far is that? Well, that's 4 units. Easy, right? 7 minus 3 is 4. I need to split 4 into 4 parts. That means each one is worth 1. So 3 plus 1, that's going to be 4. Add 1. We get a 5. Add 1. We get a 6. Yes, sometimes it's easy. Okay, which point splits us into a ratio of 3-to-1? 1, 2, 3, right here. So it's 6. The y coordinate of our answer is 6. That's how you do it when you don't have graph paper. I don't think that's super easy, but this wasn't too bad. We're going to do the same thing. We have a directed line segment that's going to go from 8, -1 to -6, -8. And we're going to partition this into a ratio of 3 to 4. So that means we are looking for 7 parts. Let's do the x's first. We're going to go from 8 to -6. If you want to know the distance between two numbers, you subtract. 8 minus a -6 is the double negative changes to a plus, so we end up with 14. I need 7 parts, so I'm going to take that 14 and divide it by 7, and I get 2. We're starting with 8. We have to land at -6. I'm going to use this little line to help me count up. I know they're going to be 2. Now, if we're going from 8 to -6, that means we are going down. The next one would be 6. Then go down 2 more. We got to go to the 4, go down 2 more, we get to 2, go down 2 more, we get to 0, and go down 2 more, we get to -2, go down 2 more, you get to -4, go down 2 more, you end up to -6. 1, 2, 3, 4, 5, 6, 7. I have 7 parts, which is the point that's going to get me 3 to 4. There's 3 pieces. There's 4 pieces, so that, now since these are the x's, that is the x coordinate of our answer. We're going to follow the same process and do it with the y's. The y's are -1 and -8. To find the distance between them, I am going to subtract. -1 minus a -8 would be -1 plus 8. That turns out to be 7. I need to take that 7 and divide it up into 7 parts, which is hella easy. That's a 1. Then I make this little helping line for myself. I'm starting at -1 and going to -8. It's moving by ones. It's just getting more negative. So it's -2, -3, -4, -5, -6, -7, -8. Find the point that splits this little segment into 3 parts to 4 parts. 3 parts, 4 parts. So -4 is the one that's going to do that. That means the y coordinate of our answer is -4. Partitioning is not that easy. If you followed all of this, once you start to work some problems that you get in class, it's probably going to get a little bit more complicated. Watch this again. Leave me any questions down below. Hey, I want to show you how angle bisectors work. I'm using my computer here so we can move things around easily and show that stuff is going to work for all angles. So angle ABC is 60 degrees, and if I move it and make it smaller or bigger, you can see that that angle number is changing, putting it back to 60. I am selecting the points of the angle again and asking my computer to give me the angle bisector. Construct that. And now we have a ray that is splitting that angle in half. Put a point on there so I can measure stuff. And we're going to measure the first half of that, the top half of it. It's 30 degrees. No way. Okay, let's measure the bottom one. Oh, the drama. Oh, the suspense. It's also 30 degrees. That's a bisector. It splits the thing in half. Let's get on and do some problems. The measure of angle XVP is 36 degrees. Find the measure of WVP. Okay, angle language. XVP, XVP is this top angle right here, and they're telling me that that one is 36 degrees. Now these congruent angle markings, if they both have one arc, that means they're the same size. I mean, we are talking about bisectors, so knowing that these two angles are the same size makes this a bisector. And that means WVP, the bottom one, is also 36 degrees. That's it. That's kind of like a question that you may see just to get an idea of whether you understand the concept. All right, this one's probably a little trickier. Let's see. Find YXP. YXP is this angle right here. And they're telling you that ZXY, oh, that's the whole thing, is 120. So the entire angle is 120, which means each one of these needs to be half of that. They're the same. So we know this is a bisector. We know they're the same because of how they're marked with the blue arcs, but we are talking bisectors here. So I'll just take 120, split it in half, and we get 60 degrees for the angle they're asking us about. The other one's also 60 degrees. Oh, cool. Algebra. I think these are fun. RQP. RQP is this angle right here. And that's 6x plus 1. So I'm going to fill that in. And SQP, which I think is the other half, but let's just double check. SQP, yep, is 5x plus 6. And since these angles are congruent, they are going to be equal to each other. So that's how you start. 6x plus 1 equals 5x plus 6. Geometry is done. Now we do algebra. I like to subtract the smaller x value, so I'm going to subtract 5x from both sides, and we're going to end up with an x. 6x minus 5x is just 1x, plus this one equals the 6, because the 5's will cancel. 5x's cancel. Now subtract 1 from both sides, and you can do that in your head. We get x equals 5, and then we were only supposed to find x. Yay! Find TSP. TSP. They want us to figure out how big this angle is. We know that TSP is 4x plus 6, so I'm going to put that in there. That's not the answer. You got to come up with the x, and we're going to plug it back in. And then the USP, which is the other side, is 6x minus 2. Since this is a bisector, these two are equal to each other. We're going to start solving, and there's more than one way to solve a problem like this when you have variables on both sides. Just out of habit for doing this forever is I like to subtract the smaller value of x because it just gives me a positive x to work with in the next line, which I like. Now, 6 equals 2x minus 2. I'm going to add the 2, so I have numbers on one side and the 2x by itself on the other side. Now we're going to divide both sides by 2 to isolate that x, and we get x equals 4. And if you stop here, you're going to get a wrong answer, but 4 is not the answer, but it's not wrong. We're just supposed to plug in and find out what TSP is. So we need to do a little bit more work, and I need a little bit more room. So 4x plus 6 is what TSP is. So I'm going to substitute this 4 that I just got into that 4x. 4 times 4 is 16. 16 plus 6 is 22 degrees. So this part is 22 degrees. Now, instead of doing a whole nother example, there's other kinds of problems you could do where they're going to ask you to maybe find the entire thing. So let's do that with this. What if they said they wanted you to find TSU? TSU, if the whole thing. Well, you already know it's a bisector, so you could do the work here and substitute the 4 in, or like me, you could just be a little lazy and go, this is a bisector, so I already know that this is 22 degrees, which means the entire thing must be 44 degrees. Now, unless I change something, this was the last lesson in the first unit, which means the next thing would be the test on this unit. My test probably won't be identical to your teacher's test, but it's going to be pretty close. And I'm sure you're going to do well if you can do all the questions that are on my test. So let's start. So this is a segment addition question, and we're supposed to find the length of TS, which is this piece right here. Right now we know it's 2x plus 28, but we don't know what x is, so we got to try to set up some kind of an equation. Well, the entire thing is given to be x plus 27. So to set up the equation, just think about this. The 2x plus the 28 plus that 10 must be the same as the x plus 27. So once you do that, you're done with the geometry. Now we're going to do a little bit of algebra. Let me simplify this. So I have 2x plus 38 equals x plus 27. And now you have variable on both sides. I like to subtract off the smaller variable, when that would be just the 1x. 2x minus x is just going to leave me with 1x plus 38 equals 27. And now we subtract 38. And we end up with x equals negative 11. Yay! Are we done? Yeah, you're going to probably get that wrong if you stop here, but you didn't do anything wrong. It's just, I want to know how long this pink piece is here. Right over here. So, I'm going to pop that in there. 2 times negative 11 plus 28. So we get negative 22 plus 28, and we end up with the answer is 6. So TS equals 6. That is finishing the problem. Minus 11, not wrong, just not finished. Next problem. Pause and give this a try. You're looking for the wrong name, so we're checking to see if you know how to name angles. Choose the wrong name. Let's take a look at what we got. Here's the angle that we're trying to name. This is the vertex, and if you have 3 letters in the angle name, the middle letter needs to be the vertex. So let's look at our choices. Can you call this just angle M? Yeah, you can. You can do that because there's only one angle here. And if you name an angle by its vertex, that's fine. You can also call it angle 4 because they put a little 4 there. NML, NML, yeah, that's okay because the M is in the middle. And M is in the middle on this one too. So the only one that isn't going to work is this one, D. This is a vocabulary question. So you just need to know what we call a 180-degree angle besides 180 degrees. That means you need to know what all these words are. Acute is an angle that is less than 90 degrees. Right is an angle that is actually equal to a 90 degrees. Exactly. Not 89, not 91, 90. Obtuse is an angle that's bigger than 90 but less than 180. And a straight angle is 180. So the correct answer here is D. Try this one. That looks pretty complicated. What do we got going here? We have to find x. Good. Angle, VUL, is 7x minus 6. Well, where is VUL? This is what we're talking about. And that's this angle right here, VUL. So this guy is the 7x minus 6. If you can draw on your paper, draw on your paper. It helps a lot. LUT is the other part of this. LUT is this angle. And that is 6 plus 13x. Okay, those two together make up the whole thing, which is going to be 160. So that's what we got to do. We're going to add those two together and make it equal to 160. And let's clean this up, simplify a little bit. This 6 and this negative 6 cancel each other out. Woohoo! 13x plus 7x is 20x, and that equals 160. Now let's divide both sides by 20. And 160 divided by 20 is 8. X equals 8. And you didn't have to plug this one back in because the question is asking us if we would just please find x, and we did. All right, try this one. Again, we got to look at these angles right here. So A and B, are they a linear pair? Well, a linear pair are two angles that are sitting right next to each other, and when you add them up, we're going to make a straight angle 180. They make a straight line when you add those together. That's not what's going on here. Adjacent just means two angles that are next to each other. They don't have to add up to anything, but these two are not right next to each other at all. Corresponding, you haven't learned that yet. You're going to learn that in the next unit. Vertical, across from each other. Well, that's these two. And if you remember the lesson that I did, I talked about a bow tie. If you see a bow tie, that's vertical angles. They are across from each other. And then obviously none of these isn't the case because the correct answer is D, vertical. Try this one. We're supposed to find the measure of angle B, and the big hint they give us here is that we've got a 90-degree angle here in the corner. That means the 28 plus B has to equal 90 degrees. Subtract the 28 from both sides, and B equals 62 degrees. Something like this, your danger on a test is that you're going to think it's harder than it is. So look out for that sort of thing. Nerves make us think everything is harder than it is. Try this one. These two make a linear pair, and that's going to add up to 180 degrees. So 6x plus 84 equals 180. So if I subtract 84 from both sides, I am going to come up with 6x equal to 96. Now divide both sides by 6, and we get x equal to 16, and that's all we were asked to do. Yeehaw! Try it. I'll be right back. These two angles are vertical angles, and vertical angles are equal to each other. The word for that is congruent. Vertical angles are congruent. So set 4x plus 3 equal to 83. Geometry done. Now you do the algebra. Subtract 3 from both sides. We're going to get 4x equals 80. Now divide both sides by 4. X equals 20. Try it. Find the midpoint of the line segment with the given endpoints. Give it a go. I'll be right back. Wait for me if you're not sure how to start. Midpoint. We know that this is an x-coordinate and this is an x-coordinate. If we plotted these two, there would be a straight line between them, and you want to find the middle of that line. But the middle is also the same thing as the average. So one thing you can do to find the middle is just add -4 plus 5 and split it in half. That's going to give you the middle. And we can do the same thing with the y's. 0 plus 4, split it in half. Whatever we get when we do these two pieces of math are going to be our answer. So -4 plus 5 is going to be a 1, so that's 1 over 2. 4 divided by 2 is 2. So our midpoint, the x-coordinate is going to be 1/2, and the y-coordinate is going to be 2. If you need to review that, go down to the description, and there'll be a link to my video on midpoints and why that works the way it does. People forget this stuff. All right, another midpoint question. Give it a shot, and if you're not sure what to do, wait for me. All right, so here's what we got going here. M is the midpoint of PQ. So here's M. It's in the middle of some segment that starts at P and ends at Q. It means that these two halves are equal to each other. PM is 8x minus 5. I'm going to put that right here. MQ is 3x plus 40, and I'm going to put that right here. And that's all you know. They're not giving you the length of the whole thing. They're not giving you any other information at all. But because it's a midpoint, it's kind of magical. It means that these two are split in half, and so these two pieces are actually equal to each other. That's the geometry. Your algebra equation is going to be 8x minus 5 equals 3x plus 40. Not everybody's going to need the diagram, but in geometry, especially on exams, drawing pictures is super helpful to see how things are related. All right, let's start solving. Subtract 3x from both sides. And we end up with 8x minus 3x is 5x. Bring the minus 5 down equals, the 3x's are going to cancel, and we end up with 40. If you need to review how to solve equations, I'll put a link down in the description somewhere for that as well. Now we're going to add 5 to both sides. If I add 5 to this side, the 5 cancels. 40 plus 5 is 45. Now divide both sides by 5 and we get x equals 9. And that's all they asked us to do. We could go farther though. Like you could substitute the x in and find out how long these pieces are. But we don't need to do that because they didn't ask us to. This is a very specific kind of problem you may see. It can be a little tricky. Give it a shot. I'll be right back. All right, here's how I taught my students to do this. You've got endpoints and midpoints. That means you have a segment. We're going to pop these points on here and fill in what we know and then figure out what we're going to do with that. So if one of the endpoints is negative 6, 7, the midpoint is 6, negative 8. So we want to find out what they're asking you to do, which could be like one of the questions is like, what the heck are they asking me? They want you to figure out what this point is over here. Now remember how midpoints work. You add the x's together. So this negative 6 plus this x divided by 2 ended up becoming this 6. So negative 6 plus x divided by 2 equals the 6. I'm going to go ahead and solve that right now before I make it any, before we do the y's. If you're going to solve an equation like this, you need to multiply both sides by 2 first to clear this fraction. Algebra. Hopefully you paid attention last year in algebra. If you didn't, that's okay. I got videos for you. You can get caught up. Now, add 6 to both sides. This is a negative 6, so you want to clear that out. You're going to have to add 6 to both sides. So we end up with x equals 12 plus 6. I added 6 to both sides. This canceled. The 6 is there. We end up with x equals 18. So that's half of our answer. They want to know what the x value is right here. It has to be 8 right here. This has to be 18. 18 plus negative 6 is 12, and 12 split in half is 6. You got to do a few of these before you see how it works. If you have homework on this that you didn't do, go do it. All right, let's do the y's. So one of my y's is 7. The other one is just y. But when I put those together and split them in half, it's supposed to be negative 8. So 7 plus y divided by 2 is negative 8. Multiply both sides by 2, just like the last time, because we're always dividing by 2 when you're working with a midpoint. And then that cancels. We get 7 plus y equals negative 16. Now I'm going to subtract 7 from the negative 16, and my y is going to be negative 23. So not the midpoint, we know that one, but this point right here is the x is 18 and the y is negative 23. You need to review that for sure, probably. So I'll put a link down below to the video that did that. Okay, try this one. Given points f, negative 5, 3, and g, 10, 8, partition FG, segment FG, at point P for a 3:2 ratio. I understand that that's probably not even sounding like English, but give it a shot. You might know how to do it. If you don't, wait for me. I'll be right back. When I teach my kids how to do this, I do not do this drawn to scale. I don't plot points. It just makes it more complicated. I just make a little helping line here. Now, we need to find a point that puts it into a 3:2 ratio. But this 3:2 ratio is the confusing part. Well, what does that mean? It means you're going to split this line not in half like a midpoint, but you're going to split it into 5 parts. The 5 comes from adding the 3 and the 2. 3 plus 2 is 5. So before I do anything more, I'm just going to put in some scratch marks and split this into 5 parts. That means you're going to put in 4 little marks because you'll have 1, 2, 3, 4, 5 sections. It's like a sub sandwich that you get, you know, from the deli, and then you split it up into 5 parts. That's what we just did. Now the P, the point we're looking for, is where you have 1, 2, 3, and then 1, 2, 3 to 2 ratio, 3 parts to 2 parts. We need to find this piece right here, this point, the coordinates of it. This is what it looks like on a scratch diagram. So let's do the math and find it. All right, so F is our starting point and G is where we're supposed to land. That's an XY and that's an XY. So how long are each one of these parts? Because that's what we need to figure out. So the length of the X's is going to be the total distance between -5 and 10, and then you'll divide that into 5 parts. Well, the total distance is going to be 10 minus the -5 divided by 5. If you had to start at -5 and go up to the 10, you would have to go 15 steps, right? You'd have to go -5 to 0 and then 10 more. So that's 15. But if you understand this subtraction, you understood this double negative changes into a plus. So we ended up with 15. Dividing that by 5 is 3. So that means that each X is going to go up 3 units. So if you started at -5, -5 plus 3 would put you at -2. So this would be -2. -5 plus 3 is -2. Then you add 3 to the -2 to go up 3 more, and you get a 1. So the X value for this point will be 1. -2 plus 3 is 1. And then add 3 to the 1, and we're at the point where we want to be at, which is 4. 1 plus 3 is 4. And if you added 3 to 4, if we keep going just to check our work, this would become a 7. And then if you add 3 to this 7, that's going to give you the 10. So the X's are all set up. Now we have to do the same thing for the Y's. This point is moving from 3 up to 8. We still need to divide that into 5 parts as well. The length of the Y's divided by 5. So 8 minus 3 divided by 5. We get 5 divided by 5, which is 1. Hecka easy. Okay, cool. We'll be able to do this pretty fast. Each Y is going up by 1. 3 plus 1 gets me to 4. So this is a 4. And 4 plus 1 is 5. And 5 plus 1 is 6. And 6 plus 1 is 7. And 7 plus 1 is 8. And everything is working. And our answer for point P is 4 to 6. You probably need to review this. This is one of the hardest ones on this test. If your teacher even did it, it's possible your teacher didn't do it. I like to do it right away because I think it's like segment addition, but that doesn't mean your teacher did. Try this one, not as hard. Each figure shows a triangle with one of its angle bisectors. There's one triangle here with one angle bisector. Bisectors split things exactly in half. That's what you need to know. So if the measure of angle 2 is 65, you're supposed to find GEF, which is the whole thing. Well, if this one is 65, this one is 65 too. So all you got to do is add those two things together and we will know the entire angle, GEF. Just add them up. Boom, we're done with that one. That was a nice break. A little more complicated. Give it a shot. All right, that blue line is an angle bisector, so we know what that means. We know that these two angles are going to be equal to each other, which means these algebra chunks are going to be equal to each other too. So 2 plus 5x equals 4x plus 7. That's the geometry. Now we do the algebra. For me, 4x is smaller than 5x, so I like to subtract that one first. And I'm going to end up with 2 plus 1x equals 7, because the 4x's cancel. And no, you don't have to draw a 1 in front of it, but I do that just to be super clear. Subtract 2 from both sides, and you end up with x equal to 5. Are we done? Are we done? Did we have to solve for x? No, they actually want to know how big angle 2 is. So let's substitute that 5 back in there. We've got 2 plus 5 times the 5. 2 plus 25, because 5 times 5 is 25, and we end up with angle 2 equals 27. If you get a little bit tired, you're going to probably go 5 and 5 and put a 10 here. Be careful. You're multiplying, but every brain gets tired, so stuff like that will happen. I'm going to give you a couple choices here. You can go back and review a lesson to get ready for your actual real-life test, or if you are ready to move on, here is the next lesson. See you guys next time. Bye.